Welcome. Today we're going to speak about the new feature in SQL Server 2012 called AlwaysOn Availability Groups. It's a next step after the Failover Cluster, and it builds on top of Failover Cluster. So the first thing we'll do in this sample, we'll just ensure that we have the Failover Cluster installed and that it has 3 nodes in it. The maximum amount of nodes in AlwaysOn Availability Groups is 5, so you may have up to 5 nodes. But in this example, we'll have just 3. It doesn't matter how many of them you have, only one of them will be read and write, and up to 4 of them will be read-only. So that's just so you wouldn't think it's a sort of NLB or network load balancing cluster. It's not. It's rather 20-80 principle in action, when 20% of your requests are for changing data and 80% read-only. So as you can see, we have the Failover cluster with 3 nodes up and running. If you don't know how to set up the Failover cluster, you can see another video. I think link will be in the description in YouTube and also in the blog post. I'm trying to click the start. In Windows Server 2012, it allows you some time to think whether or not you want to press start button. So, we're just going to SQL Server Configuration Manager, and there is a new tab called AlwaysOn High Availability. And as you can see, we gave this cluster name MIA cluster, and we check the Enable AlwaysOn Availability Groups checkbox. Make sure that in your configuration you have the same. Obviously, name can be different. So I click Cancel because we don't need to change anything here. I'm just showing you that that's what we have as a prerequisite for AlwaysOn Availability Group. Now let's go to SQL Server Management Studio. And we are logging into first node, which is MIA Cluster 1. We don't need to log in to other nodes. And the first thing that we will do, since this node is hosting 2 databases, we will back up these databases. All nodes share the same storage, so they all have the access to the same storage. It's not a prerequisite, but that's what we have here. Ensure that the backup type is full backup, and here drive D is common for all nodes. They all have access to it through network share, and the first database is human resources, and we just back it up. In this particular case, our databases are about 4 megabytes large, which is just like nothing. In your environment, obviously, even backup procedure may take hours. So make sure you reserve some time, some downtime for installing the AlwaysOn Availability Group. So we're backing up the second database. So our AlwaysOn Availability Group will make sure that these 2 databases are always available, And now, as you can see, we have here a new thing in SQL Server 2012 called AlwaysOn High Availability, and we can create new availability group here. We'll use a wizard in this case. Just click next and give it a name. Well, it can be anything. In this case, we'll call it MIA SQL AG, which means availability group, but it doesn't really matter how you will name it. We'll select both databases. And here, as you can see, we have just one node at the moment, which is the primary node. We can have only one primary node, of course, and so we'll have to add 2 additional nodes, class 2 and class 3. And in the first tab, you will see such columns as automatic failover, and you may have up to 2 nodes in automatic failover. Synchronous commit, which means that data will be replicated synchronously at the same time without delays, or asynchronously, which means with delays. So we're adding a second and third node. And we'll do some adjustments here. When the cluster 1, the first node, will fail over, which means it will fail, we will want class 2 to take its place. So we'll set it as automatic failover for class 2, but not for class 3. And synchronous commit is a must-have for such node. The class 3 will only be able to become primary after manual action, because it's not synchronous commit, and in that case most likely we will lose some data, some latest updates. Another thing that you see here is readable secondary. Please read the blog post which explains more about readable secondary. Basically it means that you can read the data from this secondary nodes. By default you cannot, but the beauty of availability groups is that you can read data from all nodes and you can write to only the primary node. So we'll make some adjustments here. We'll set the second node as read intent only, and node 3 as just a readable secondary. The only difference here is that for read intent only you will have to specify so-called intent in the connection string. So without that intent you will not be able to do anything, as you will see an example later. And if you say yes, well, you will be able to connect with the ordinary connection string. Anyway, it doesn't mean that you can update data on your secondary node. No, you cannot. This is not network load balancing cluster. Even though it has some features of network load balancing cluster, like for example, if you are connecting to the availability group by its own DNS name, and you specify, for example, that your intent is read intent only, you may be directed to read-only node. So for class 3 we will select yes. We'll leave it as non-automatic failover because we cannot add third node to it, and synchronous commit is switched off, so we'll spare some traffic. Here in endpoints, the interesting part is encrypt data. If your servers, if your nodes are in the same server rack, or they are just different virtual machines in the same host, perhaps you will not need to encrypt data, as it will bring some disadvantages in terms of performance, especially for CPU. In this case, we will leave it as is, so data will be encrypted. Also, if you will encrypt the data, the initial synchronization will take significantly longer. Even though in SQL Server 2012 the default algorithm is IS, so it's fast enough, but anyway, sometimes you just don't need it. Backup preferences, we'll leave it as is, so we'll prefer the secondary node to unload the primary node. In the blog I will explain it a bit deeper. Basically it means that you can create your backups on secondary nodes, so your primary node, which is the main horse or workhorse in this availability group, will not have to waste resources, especially when you are compressing your backups. CPU will suffer, and so will your end users. As you can see, there is a backup priority, so you may choose that any particular node will get the chance to create backup more often. And some nodes, which we call replicas, can be excluded. A listener is what brings the NLB features to our availability group. It's basically the name that you can use to connect to this cluster. So you will not have to connect to any particular node. You will be connecting to this DNS name, and once you will put it here, it will be automatically created. So when you're connecting to your availability group by this name, you will automatically be redirected to the current primary node. Obviously, when you will try to connect directly to any node and the node is down, you will not get connection, you will not be redirected. So we put a normal SQL Server port here. We assign a static address, which is usually considered a good practice. And let's just add the address, which is 10.10.0.40. Obviously, your nodes can belong to different subnets. They can be geographically in different places. So that's why we created the backup of the databases, because all nodes will begin with restoring the backup from that path, which is the same for all of them. We are going through validation, and then here's the sort of table of contents for our script. And as you can see, there is a little script button which would allow you to save the script in case you want to recreate that availability group later, say on customers' premises, whatever. Do not go through a wizard, but to make it automatically. In normal scenario, obviously this will take maybe hours. It depends from the size of your database, because it will have to be restored and synchronized among a few nodes. In this particular case, with two databases, 4 megabytes each, it will take less than 1 minute. That's it. And as you can see in SQL Server Management Studio, we've got our availability group. And if you right-click your group name and click the Show Dashboard, you will see the dashboard for that availability group, and it shows you at a glance what's happening. So we see that third node, okay, now it's synchronizing. But as you can see, first and second node are already synchronized, while third one, which is synchronized asynchronously, is still synchronizing, and it will take minutes till it will become synchronized. Now that we've installed the availability group, let's play with it a little bit and see what will happen if we connect. What happens when we are connecting to that availability group? What happens when one of the nodes fail? Or what happens? What can we do when we want to do some maintenance in one of the nodes and we want to switch the primary role to another node? So we're going to command prompt. We connect to our availability group by its listener name, which is Mia SQL Cluster in this case. And let's try to select some data. Actually, first thing that we'll select is a server name, just to see to which node we are connected. It's Mia Cluster 1. So as you can see, the Mia Cluster 1 is the primary instance. And now we'll select some data. No, it will not work here. It will not work because we must give every command in its own row. Yeah. So let's try to do it again. Yep. So we tried to connect to availability group. We were redirected to the primary instance, and we are able to select some data. Since we are connected to primary instance, we can also change data. It's not a problem. So let's try to connect to other nodes and see what we can do. Now we are connecting to the third node, which is replicated asynchronously. And we can retrieve some data. And as you remember, when we set up this availability group, it was set as active secondary replica, and without specifying the intent, unlike the class 2 node, the second node, which requires the intent in the connection string. And as you can see, if we'll try to get some data from class 2, from the second node, it should give us the error because we didn't specify any intent in the connection string. Let's say go, and as you can see, the error message that the target database is an availability group and is currently accessible for connections with the application intent is set to read-only. We didn't set any intent. So class 3 is able to serve any connections without intent. The class 2 can only serve connections with intent specified, but both perform the same. They both are read-only. You cannot change data whether or not you specify the intent. So let's start the Failover Wizard. And the Failover Wizard is what you can use to switch the primary replica. So for example, if class 1 needs some maintenance, we know that it will not be able to serve any customers. We can now choose a new primary replica, either class 2 or class 3, and with class 2 it's not a problem because it's replicated synchronously. No data loss is expected. Class 3 is asynchronous replica, which means asynchronous commit, which means all the changes come to that node after some time, could be seconds. So chances are we will lose some data. And as you can see, the failover mode for class 2 is automatic, which means if class 1 will go down, the class 2 will automatically become the primary replica. Class 3, its failover mode is manual, which means we can only do it manually by providing a command or using this wizard. So what we'll do, we will select class 2 as a new primary node. Otherwise we would lose some data, perhaps. Next, we are not connected to class 2 yet, so we have to click connect button and provide the username. We're using Windows authentication. So we have connected, and well, that's like it. Again, you can click the script button to export the script to change replica. But now we click the finish and the changes are made. And class 2, the second node, becomes the primary replica for this availability group. Although you see here in the dashboard that there are some errors, blah blah blah, in fact there are no problems for end users at the moment. They still can connect to this availability group, and as you can see, since the auto refresh is on in this dashboard, everything is okay. Now the primary instance is class 2. The class 1 became the secondary node. And let's just connect to this cluster. And select the server name, which will allow us to see to which node we are connected. So now it's class 2, which is the primary node for this availability group. But that was the manual failover. That's what we do manually when we need to change the primary instance. However, what happens if the node goes down because of some technical problem? To simulate that, what we'll do, we will stop the SQL Server on class 2 on the second node, which is the primary instance now in this availability group. And well, it simulates the technical problem in the node. And now the class 1 immediately became the primary node in this availability group. Class 2 is down, as you can see, it's not synchronizing. The class 3 is not down, and we'll see it now, I think. Yep. Class 3 is okay now as well. Class 2 is not okay because the SQL Server is not running. The next thing that we'll need to do in this example, we'll try to start the SQL Server on that second node and see what will happen. Where is the command? Yeah, by the way, if we'll connect to that cluster, select the server name, then obviously it's class 1 now. Because class 2 is down, class 1 became the primary instance. Oh yeah, of course. Bright mind. I'm trying to start the SQL Server from the SQL Server command prompt. Obviously it will not work, so I'll do it manually. I had to exit that SQL prompt. Disregard that. It's like in all demos, you will have the error. So we've started the SQL Server on class 2. In a few seconds it will start, and availability group will be able to connect to it, to communicate with it. Yep. So now, as you can see, class 1 still is the primary instance. Class 2 doesn't regain the primary role, but it becomes back the secondary node in this availability group. And well, our availability group is running up, it's healthy, everything is okay, and well, that's like it.